in order to avoid to be out of schedule, maybe we shall start with the presentation that was planned to be the second presentation for Professor Dr. Engineer Nade Troussier. Are you here? Do you agree to do your presentation now?
Yes, I'm ready if you need.
Okay, so your presentation will be, well, thank you for presenting today. You're from the UTT, so University Technological University of Troyes. And your presentation is from industrial ecology and eco-design towards design for strong sustainability. I will let you share your screen. Do you succeed to share your screen? Yes, it's coming. Okay, so
that should change my Zoom visualization to see my PowerPoint.
yes, if you could put it on full screen, it would be perfect.
Yeah, but I have to see that. I think it will come. Is it okay?
Yes, perfect. Thank you.
Okay. So I'm happy to be with you today, and very happy for the invitation I had to participate in this day. I'm going to talk about the research work we are doing in a research team, which is an interdisciplinary research team, where we work on transition towards sustainability of social and technical systems, in which we can consider manufacturing system are. So the name of the team is CRED. I put it there because I will make some reference to our website. So if you need to find it, you can use this keyword to find our website. So our main topics is we are part of the University of Technologies, and our main issue is to understand the link between technology and sustainability. And from that, we study the link that exists between natural ecosystem, considering living life, mineral, water, air, and society and technology, which are from our perspective, something which is really the same thing. Human is really linked with technology, and it is the reason, reason for not being in the animal part in our view of the life on Earth. Our main issue is really to deal with what would be the technology tomorrow, considering resource consumption, waste management, environmental impacts stakes. So for that, we have a team of permanent staff coming from different disciplines, epistemology and philosophy, management, development, as urban planning, and engineering, so mechanical engineering, industrial engineering, energy and processes. And we all focus on the same question, which is what is sustainability and what can be transition in sustainable system of productions and territories and organization. And we try to develop an holistic approach concerning the interrelation between these different dimensions. So here is a very loud slide. I will just use it for the time scale. I put the slide as it is on our website. So if you need to take time to read, you can go to our website and you will find this slide. But I will use it just to explain how we evolve in our research trajectory to come from understanding sustainability, trying to implement and deploy it with industrial ecology and eco-design, and then coming today to a new perspective on strong sustainability. So I will start with the first stage in our research. So just coming back, we started this research team just after 2000, and then it is concerning the 5 first years of the life of the research team. We were working on definition of sustainable development and sustainability concept to understand what it is. with the first scientific posture, which is that economic development and human development are compatible and can be combined, and an hypothesis on the fact that if we reproduce natural cycles in human activities, then it can enable the compatibility. And then it was a starting point to understand what is sustainability, considering sustainability as the ability we can have to answer our needs today, but also enable future generations to answer their own needs in centuries. So we started with the principle of industrial ecology in order to understand the theoretical and scientific basis and as a way for revising industrial organization and try to copy natural cycles to rethink industrial organization. From the next step, so the 10 following years, after having understanding this theoretical principle and what can be sustainability, then we spent 10 years trying to deploy this principle in practice. So in this second step, we identified a big limitation, which is that organization of production system depends on product definition. So to work on our hypothesis, which is reproduction of natural cycles in human activity, enables the compatibility. We had to act as soon as possible, trying to anticipate potential impacts instead of reducing implied impacts. That means instead of working on, for instance, manufacturing of existing manufacture, existing sites, we have to focus on design aspects that are really determinant in the way we will have impact afterwards. So we decided to focus a little bit more on territorial and industrial ecology with still theoretical and scientific basis, and to try to work on the evolution of spatial and temporal organization of manufacturing system. And we also develop knowledge on eco-design as a set of methodologies to design and assess product that requires an organization to be produced, and then try to minimize at the beginning of the design process all the potential ecological impacts first, and try to work also on social impacts. So during that 10 years, we developed an integrated approach with two input views. The one is coming from the territory seen as an arrangement of material, human, and symbolic resources able to structure the practice, both at the individual and collective social level. And the other view is the product view. A product as a result of human activity in the form of good, a service or product service system, which is associated with the use, so with human use. And we, from one side, we were using industrial and territorial ecology methodologies, so with analyzing flow of materials, water and energy, and also development strategies, but also collective action, collaboration, and governance analysis. And on product side, we were working on eco-design methodologies in order to protect the environment from design, to develop life cycle impact assessment, and also have a multi-step and multi-criteria approach all along the life cycle analysis. And for that, we defined some foresights from governance principles. We developed some strategies and manufacturing strategies using modeling, decision support, and assessment methodologies. It led us to develop an analysis frameworks with, there is no animation, but you have 3 different levels. So the bottom level is the manufacturing scale, And we studied the interaction with the territory scale in the middle, which is the link between the possibility of development at the manufacturing scale into a specific place, and in the other sense, how a specific place enable manufacturing systems to have different kind of development strategies. And then we have the top level, which is the planetary scale, which is really important for both the environmental impact scales, such as climate change, which is at this level, but also for big regulation scales, when you have intergovernmental rules that are defined, that are based on assumptions. Then we were studying how it was developed at territory scale and in manufacturing scale, and then try to evaluate, to assess if the initial assumptions that were done at the planetary scale are proved or not in the way it is put in use at the different levels. So it led us to study from resource management perspective, from value networks, and from environmental, economic, and social impacts perspective. We address some questions such as what positioning of technology in society, what prospects and associated way of manage that, of governance, and which kind of acceptability or integration of this evolution. At the territory scale, we were focusing on what kind of link we have between territory development and industrial development. What are the structuring of the sectors, activity sectors we have, and does sustainability change the structuring? And also, what are the collaboration that have to be put in use at the local scale between public actors, farmers, companies, and how we have to develop linkages to change the manufacturing model. And at the bottom scale, the practices questions were how we could design production systems, what kind of deployment of methodologies, and what are the main stakes around this deployment perspective. What tools of scripting, evaluation, decision support we can put in use to make practices evolve, which kind of company territory integration should be done, and what kind of indicator we should use at this level to see if the evolution is coming. So then we switch to another step in our research that were then to try to couple the analysis of spatial and temporal networks development of actors, so actors that are both actors of the manufacturing system, but at the same time actors on the territories they are acting in, with the analysis of product and technical system development using the territory concept that enable us to manage different scales of geography, so different spatial scales, but also different time scales considering past, present, and future at different scale. So the main questions that remain with that was linked with the establishment of synergy and the management of energy, material flow, and eco-design that can enable a sustainable, human sustainable development. So it forced us to consider long temporality, to be able to have a shared vision of construction and difficulty of deployment, because it's quite difficult to consider this long temporality in all the actors' decisions. But it is a necessity to consider sustainability stakes. We had many technical and human factors that are involved in this kind of process of building scenarios of development. And we have trends toward the implementation of what we call low sustainability solutions. That mean we have objectives and ecological and social impacts are constraints we try to manage in a mainstream model that we are still working in. And then we had the question that which kind of methodology we can use to have more strong sustainability. That means consider sustainability such as constraints that are there, because, for instance, just for instance, for climate change or biodiversity, we have scientific facts that demonstrate that today we are already facing some big stakes, and we have to take it as a new context, for instance, to develop manufacturing systems, and not try to develop manufacturing systems to decrease the future impacts in still the same context. So we wanted to work much more on this strong sustainability view that enable to imagine a context which is the real one we are not so much working on, which is we have ecological and social context, and we have to learn how to develop technology in this new context. So the main question is what kind of knowledge is necessary to develop, what kind of geographical and spatial perimeters we have to consider in which temporalities. So it is also shared with other research in this domain. Here you have a picture which is extracted from a publication from Italy, and they were analyzing all the past research publications that were addressing the problem of the stakes of sustainability. And then we see that a long time, the perimeter to consider was obliged to evolve to try to address the problem and to come into a socio-technical system level because there were too much interactions between technical definition, social behavior, to consider these things as independent things. And a question linked with that are, for instance, what time scales of projection and action should be considered. And we have to articulate temporality of the action and the decision in the company, and temporality of the effect of this action, which can be very long-term one. So we built an analysis framework considering different systems perimeters coming from product to territory levels, and also different time scales to assess ecological and social impacts, and considering different level of uncertainties, because higher the geographical level is and higher the time, and longer the time scale is, more the uncertainties have impacts on the assessment methodologies. And finally, we finish with our fourth step that really want to assume a strong sustainability scientific posture. That means considering that we have environmental constraints we will face, and that human development is the priority as adaptation to environment evolution, and then not anymore try to reduce impacts, but really to adapt to a new living context, which is what we can call strong sustainability. So the hypothesis we are doing actually is that in this view, there are spaces where a network of actors can adapt to solve their adaptation problems. And the scale of the ability to change the states of our society and then also of manufacturing system could be a scale for sustainability. So we will not have one global model for sustainability, but local models of sustainabilities. Then we are considering some cases where we have big environmental constraints, that means big financial constraints, social and ecological ones. And the question is how to understand the transition, the new practice we should put in use to be able to evolve in this new context. So for that, we use the territory concept that enable to manage different scales of analysis and different time scales analysis. And it is for us a means to study the transition phenomena. And then we try from that to develop new methodologies in strong sustainability to assess sustainability both in its ecological and social dimensions. So, for instance, using circles of sustainability, donut model, etc. Just the challenges then for us, then it's to develop new adaptation, knowledge and skill by practicing. That means all research practice is really linked with experimentation. We try by that to also fasten knowledge transfer in society. So we are much more focusing today in the modification of society than modification of specific companies. And we try to fasten people involvement to develop knowledge transfer. And the objective is not to develop economic models, but to develop knowledge transfer into society. So for us, it really opened the scope. It mixed a lot of activity, and it can also change the academic model and the way we are working between academic, industry, and society. So I think it is nearly the end of the presentation. So I will jump to the last slide. Just to tell that we really want to try to find some really constrained situation to study if strong sustainability is possible and if we are able to define new manufacturing organization in this framework. And for that, the main issue we have is to be able to develop multiple and risky visions. So being able to make strong assumptions, develop awareness about sustainability and culture about that massively, and then to try to deploy sensibilization activities, but also models and defining new methodology in this framework, and also to make methodology coming from disciplines evolve, taking into account the current transitions. I will stop there. I think that's enough.
Thank you, Professor Troussier, for your presentation and keeping track of the time for us. So the idea of the question session now is to have to confront the academic and industrial point of view regarding sustainability. So as usual, you can ask your question in the chat, and we will relay them. There was one question that was asked during the first presentation. I think it would be interesting to have both your point of view on this question. Professor Troussier answered in the chat, but maybe it's interesting that you also have more time to elaborate your answer. The question is, do you consider that currently there is an active orientation of both industrial companies and territorial authorities to become more active utilizer of sustainable development assessment tools or methods? And is there any real development for these approaches? So I don't know.
Yes, I can react. I wrote in the chat that yes, there are real deployment and there are real interests around that. We have a lot of contact with companies where we have people that try to make their practice evolve and are interested in experimenting today new design and manufacturing methodologies that are much more integrated, such as low-tech approach or frugal engineering. And we collaborate to follow the experiments and try to see if they're unable to work in really constrained situation. And the opportunity also around that is to develop new collaboration especially for industry, concerning link with NGOs or social and solidarity economy, which is another sector of the economy, but that can help to answer some industrial stakes, such as, for instance, recruitment stakes that are big stakes in industry today, to deal with for industry 4.0 to have the right skills. We had that in this morning presentation, trying to be able to make people learn and to be adapted to this new digitalized industry. And just to give an example, for instance, we have linked with people that are much more working on wood transformation for insertion of people that are very far for employment. And they had to develop new machines because to make these people work in this wood transformation manufacturing set, they have to be much more using joysticks or this kind of things, because they had people that can manage very easily to play video games, for instance. But then they have to really have a digitalized manufacturing processes, and they provide these people to massive normal industry, and building this link make also the industry 4.0 evolve faster, because they can have different skills with the people that are not the normal, usual people they recruit in their manufacturing seats. They develop this kind of new processes, interfaces, because of big social constraints. It is what is interesting. Trying to find some big constraints in specific practices make innovation come. And we also, this morning, we also have one of the presenters that were talking about the integrated learning process in the shop floor. It is also things they have in this kind of economy that we cannot find so much in current industrial practices. So I think that building this kind of links, trying to search for very constrained framework, enable to be much more innovative and adapted to digitalized and reconfigurable context. Sorry.
Thank you, for Professor Troussier, for your answer. Mr. Maisonneuve, do you want to react to this answer or to the question?
Yes, there is a question about the reality of the eco-design or green impact on the market. So to be honest, today that's still the beginning. From the market, we start to see on the request for quotation, we start to see on the contract some demand about environment impact of the production. So that's still the beginning. I think the real benefits will appear when the regulation and the law will impose to the people to measure the carbon footprint, for example, of the production. And I'm pretty sure that it's for tomorrow. This is what we know, what we had at the beginning of the century when we forbid the lead on the production. We had some strong recommendation or strong requirement at the beginning of the century, and when we see that 10 years after, it was okay. So I believe that it will come soon. About another question. Okay, now about the reality of the modular line. For sure, what I show you this morning, it's the final target. At the beginning, if we are able to manage a ramp-up phase and end of life phase, that will be nice. That will be nice because during the ramp-up, you have some equipment, so you use some meter square. You invest a lot, and finally during 6 months and sometimes 1 year, you don't use the equipment full time. So the modular line can help during this phase, this transition phase. For sure, at the end, the goal is to be able as well to change every month. Why not the configuration of the backend for my case?